Welcome to Pro Tips to improve your validator performance for home stakers, because I myself am not a professional, and this is instead a distillation of my own learnings from the actual professionals like Thorsten, where is he? Maybe he's outside, and from like p2p.org. So without further ado, let's begin. My name is Sam, also known as Stakesaurus on Twitter. You can find me on Twitter with this handle. I basically run Ethereum validators from home on consumer hardware, on residential internet connection, and on residential power lines. I run a full validator, 32 ETH. I also use Lido CSM, I use SSV, I use OBOL, the whole shebang. All right, I have a very straightforward agenda for you guys today. Just 3 things. How is performance measured for your validator? What can we do to improve performance? And actionable steps and tools for you guys to use. Okay, first topic, how is performance measured? All right, so let's start from the validator rewards. There are 4 types of rewards to take note of: attestations, in committee and block proposals, transaction tips, MEV. Don't need to know what exactly they mean, just need to know that attestations are stable and consistent. The other 3 types are random. All right, attestation rewards are also contributing to the highest weightage of your total rewards, 75%. All right, now given that attestations are the most important reward type, they are constant duties assigned once per epoch per validator. If you perform your duties, you get rewards. If you miss these duties, you get penalties. If you perform these duties better, you get higher rewards. And because of all these characteristics, it is the most measurable reward type, and is the one that you can most reliably improve on. Okay, so if you optimize these stable and consistent rewards type, you also get to optimize the random duties. So let's just focus on attestations. Okay. Attestation duties are made up of 3 types of votes: source vote, target vote, and head vote. Starting from the source vote, this is where you vote on the first slot of the previous epoch, all right? And it is the easiest to get right because it is at least 32 slots old, so it is already widely propagated. Second type of voting is on the first slot of the current epoch. This is called the target vote. It is also easy to get right. Slightly harder, but also still easy, because it is also an old and well-propagated duty. The hardest to get right is head vote. You are voting on your assigned slot in the current epoch, N of 32. It could be like 15, 16, 17, etc. It's usually only like a few seconds old, maybe less than that, and it's still being propagated. So there is the most room for improvement on head vote. All right? So what affects your head vote performance? There are 2 axes here: timeliness and correctness. All right. So your head vote this is assuming you don't miss your duties. All right. Assuming you perform your duties, there are 4 categories you can fall into. It can be timely and correct, where you get full rewards. Timely but incorrect, you get reduced rewards. Untimely but correct, even lower rewards. Untimely and incorrect, minimal rewards. All right. So you might have noticed that timeliness is the more important factor here of the 2. And in fact, incorrect head votes are also caused by timeliness issues. Okay, so then how do we measure head vote performance? You can go onto a rated network, you key in your validator ID or your validator public key, and you can see 3 main scoring here. Your participation rate, which is basically the votes that you did not miss. Inclusion delay, which measures timeliness. Correctness, which measures correctness. All right? And the Raver score is an aggregation of these 3 metrics. All right. So if timeliness is the more important factor here, what can we do to improve timeliness? All right. So if you break down like block timeliness, there's 3 factors affecting it. Block arrival speed, your own block import speed. This is your how fast you process the blocks once you receive it. And then after you process the block, you need to broadcast it to the rest of the network. All right, so block arrival speed is affected by direct connection to quality peers, network latency, and closer location to other validators. It is the same for broadcasting speed. So receiving and sending out affected by the same factors. And how to improve this? You can open your pods, do port forwarding, get a better network using a better ISP. You can optimize part of your networks. You can try to bootstrap peers, but this is less feasible because many home stakers, solo stakers, they like to stay anonymous. You can also improve your location, but it's not feasible and it's also not good for decentralization. Improving location means you get closer to like large pools of other validators. Yeah. All right. So, which means opening pods, better ISP, network optimization. These are the 3 feasible activities you can do. All right. How to improve your block import speed? You can get better hardware quality, better software quality. You get a better SSD, get a better CPU, at least 32 GB of RAM, good heat control or temperature control, and you can keep your client versions up to date. Super simple, right? All right, so before we move on further to the actionable steps, let's take a look at where we are at so far. Okay, how to improve validator performance? We start from the validator rewards, of which attestations are the most important because it has the highest weightage. Attestations are broken down into source, target, and head vote. Head vote has the most room to improve. Factors affecting head vote performance is timeliness and accuracy. Improving timeliness also improves accuracy, so let's focus on timeliness, of which there are 2 factors affecting it: block arrival and propagation speed, and block import speed. All right? And this is what it's affected by. How to improve? If you take a picture, and give me your comments as well. Okay. Now, for the actual actionable steps. Okay, in my opinion, there are 7 pillars of a good node operator, and this is inspired by Thorsten or Yorick. Please, you can check out his work. He runs a crypto manufacturer, a professional node operator, and also he's the creator of Eve Docker package that makes the quality of life of home stakers a lot better. All right, so there's, you can have good hardware, better network, optimize your network. You can tune your device. You should patch, basically update your clients like it's your job. Do it diligently. You can run automation tools, use automation tools, and you should definitely have monitoring and alerts system on your setup. So I like to think of it as the Infinity Stones and Infinity Gauntlet, right? All right, so for good hardware, what do we need? Okay, 3 key components to take note of: CPU, RAM, and disk. For your CPU, and this is taken from the latest recommendations from the Ethereum Foundation. It's going to be baked into an EIP, I believe. For CPU, you need at least 4 cores and 8 threads. And for heat control, you want it to have a thermal paste. Usually when you buy it from a reliable supplier, they should sort this out for you by default. For RAM, you want at least 32 GB, or even better, 64 GB. RAM is cheap. Upgrading from 32 to 64 maybe costs you less than 50 USD. Make sure it's at least DDR4. Yeah. Actually, just go for DDR4. DDR5 provides no meaningful benefits, and it's more expensive for DDR5. For disk, you definitely need an NVMe SSD. You want at least 2 TB, but ideally 4 terabytes. You want to look for something called like TLC and DRAM, which basically speeds up the SSD processing speed. These metrics are taken by from the recommendations of the EIP. Sequential read and write, you need 7,000 Mbps. Random read and write, 1 million IOPS. So IOPS and Mbps are different measures, different metrics, so just take note of that. And there is a way to run a command to measure these metrics. And a lot of times, the merchants of SSDs, they will also provide you these 2 important metrics. Yeah? For your SSDs, you also need some type of thermal control. So instead of a paste, it will be in the form of a pad. So reliable suppliers will also provide you with that. All right, final note is to place your node somewhere cool and well ventilated, because heat will throttle your performance, and shorten the lifespan of your hardware. Okay, 2, second infinity stone, better network. Recommended is 50 Mbps download, 25 Mbps upload. We aim for a layer 2 ISP and try to avoid a layer 3 ISP. A lot of times, we have no choice in this matter for residential internet connection, but even if you can't do that, make sure you have an uncapped, maybe not throughput, uncapped data, so they don't stop you at like 1 TB of data transfers, right? It needs to be uncapped. You don't want it to be behind a CG net. A CG net means that you are not assigned a public IP, right? Everything is behind a private network. Ideally, you want a static IP address or at least a dynamic IP address so that you can do something called port forwarding. Yeah, and port forwarding allows you to discover peers better. It allows other nodes to discover your node as a peer better. Right, how do you get a static IP? Some countries, like Singapore, is very easy. It's a simple add-on purchase or either one-off or a subscription basis. But not all ISPs provide this service. Sometimes, like in Malaysia, you need to submit a special request to these ISPs. And you need to give reasons such as, I need to put a home CCTV in my home because my baby is at home alone. I need to know if things go wrong. Maybe I want to host a Minecraft server, a game server, yeah, and you may need to show proof. Why I say proof is because, so this is a playbook submitted or contributed by a solo staker in Malaysia. And yeah, it lays out the exact steps for you to get a static IP from the ISPs in Malaysia, right? Yep, you can optimize your network. First step is to get a decent router. And you want to connect all devices to this router, all right, so that the dedicated router does all of the heavy routing work. Sometimes ISPs, the technicians will just tell you, you can connect to the ONR. ONR is called the optical network router. It's a modem plus router, two-in-one device thing that they like to do nowadays, which kind of does the routing job a bit not so optimally. Yep, so definitely get a dedicated router, a decent one, and connect your node and the other home devices through that, like your mesh Wi-Fi device. You want to do port forwarding, if possible. And there's also this quality of service or QoS priority setting that you can do on your node, and it is set on your router. All right, tuning, right? This is on the device itself. This is what you can do. Three main configurations here. For timekeeping, you can use the Crony package instead of the default time date CTL. And what it does is basically it uses a pool of different NTP servers. NTP means network time protocol to keep time. Because it uses a pool, it's less dependent on a single server and reduces a single point of failure. There's less drift and it's more accurate in general. You can also speed up your disk by doing something called no A time. Right? You set this on your SSD, it will disable timestamping, which Ethereum validator nodes do not need. It speeds up your read and write speed, and it also extends your SSD lifetime. Final configuration is that you can remove or lower swappiness entirely if you have more than 32 GB of RAM. And it basically minimizes the swap space usage, which is slower than using RAM. Right, automation. Okay, basically, we try to automate as much of our work as possible as home stakers because we have actual jobs to do. This is not a full-time job. It saves time managing your validator node overall, and these are some of the tools available that integrates with Lido CSM. DepNode, no-code tool. Sedge is a no-code tool. Ethereum is a no-code tool. If Docker, some code. If Pillar, some code. Right? Some code, but very low. You have a much easier time doing your patching, to update your clients and troubleshooting, and there's less room overall to make major mistakes if you use these automation tools. You can also do some more advanced automation, like introducing an uninterruptible power supply. Basically, this is like a backup battery for your validator nodes. And if it's a smart UPS, you can do something very cool, such as instructing your devices to automatically shut themselves down when the mainline power is being cut. Right? So what it does is that it prevents database corruption and downtime. Because when there's an unclean shutdown, if your database is corrupted, you have to resync from scratch, and it's very painful. It might take like 2 days, and you're offline for 2 days and get penalties. And if you get assigned with a sync committee duty or block proposal during that time, it's so painful. Yeah, you can take it a step further. Once the mainline power is restored, the UPS will be smart enough to send a power on instruction to all of your devices. All right, so if you do this advanced monitoring setup, then you can go to the ECC with a peace of mind. You don't need to be afraid of blackouts, and then now you have to fly back early to fix your setup. All right. Number 6, patch like is your job. Okay, so basically, we need to perform timely updates to the appropriate stable versions of the different clients that we are using to get performance improvement features. Yeah, and these priority levels and recommendations will be provided by the individual client teams. For example, this is I believe this Lighthouse. During the Pectra update, they tell who should have high priority updating this to this version. Okay. But you can also combine automation with patching. So you spend less time manually updating your client versions, and you spend more time understanding what is it that you're doing, what benefits you're getting, right? And then which other client combinations are compatible with this new upgrade. So this is, I think this is Lighthouse, and this is a compatibility matrix with OBOL. All right, the most important part, in my opinion, is basically knowing when things are not going right or knowing when things go wrong. So basic monitoring and alerts, you have on-chain monitoring, which alerts you on when you miss duties and when you have upcoming heavy duties like sync committee and block proposals. So you can do this using beacon chain or if duties. It's very easy to use. Just input your validator public key and you'll start monitoring and alerting you. If you want to monitor uptime or activity on the node level, then you can't rely solely on on-chain alerts. You need to have alerts happening or monitoring on your device itself. So for that, Iridian and myself, we have our own custom solution. But if you want to really bring your monitoring game up to the next level, then you have advanced monitoring and alerts, which you can check out Lido's tool called EVM, Ethereum Validators Monitoring, or if Staker has a monitoring setup by Remy Roy as well. And this basically uses something called Prometheus and Grafana to give you a whole dashboard. You can monitor any metric you desire on your device. And, okay, so you don't really need to understand like this diagram. It's just for illustration. But next thing is important is, what if your monitoring system itself goes down? So you need something to monitor your monitoring system. Yeah? If your monitoring system goes down, you don't know when things are going wrong. So you need to know that. And what you can do is you can use something called healthchecks.io, which monitors your monitoring system. And I think that's all I have. Thank you. So if you guys want the actual links for the tools I shared, right? Feel free to reach out to me and DM me on Twitter. All right. Thank you.